Hi guys, and welcome to my channel. This is my first video, and it's about the theorem of intersecting chords. I've already written everything down, because I'm writing on a book and it can be very difficult and challenging to write whilst I hold a camera because I'm filming with my phone. So yeah, here is the diagram. Here I've covered everything with a paper, so I'm just gonna slide the paper down so that we can do everything step by step, which is similar to writing. So here is our circle, and you have our cyclic chord A, B, C, and D, and I've drawn this diagonals of that chord, diagonal DB and AC. Yeah, we have to prove, of course. Here's what we are proving, that AC is equals to BD. And now going back to our cyclic chord, you can see that the angle DBC, which is this one here, is of course equal to this one, which is DAC, and the reason is, of course, they are both subtended by the same chord. Wait a minute, they're both subtended by the same chord, which is DC, sorry. And likewise, of course, this chord here, AB, subtends these two angles, which are both equal, that is ADB and ACB, both equal to 1. They are both subtended by AB, and therefore they are equal. And going down one step down, wait a minute, you can see here you have, it's not clear, but you have here O2 and O1, and they are equal because they are vertically opposite angles. And of course it's easy to prove that they are, because this O1 here is equals to 180 minus this angle, and so is O2 is also equal to 180 minus this angle. So they're both equal always. And that leads us to another step here. Therefore, you have three angles equal in a triangle. That of course means that those two triangles are similar to one another, because all three angles are equal. So we've proven similarity there. We're going down another step. But if you're having similar triangles, what does that mean? It means that the other triangle is just scaled up by factor k for all three sides, so we can look at sides that correspond to one another. So you have here the side adjacent to angle x and O1 corresponds with the side that is adjacent to angle x and O2, because O2 and O1 are equal on the smaller triangle. And that means that you can write B in terms of A. B is simply, what is it here? B is simply A times K, and the same is true for C and D, that C is simply, C is simply D times K, of course. And of course we get to this point here, which is A over D is of course equals to A times K over D times K. But we know, of course, A times K is B and D times K is C, so we substitute here, we get A over D is equal to B over C. In here we can cross multiply in this manner, multiplying both sides by this product, C times D. This side we cancel D, and this side we are able to cancel C, which leaves us here A times C is of course equals to B times D. And finally, Diagonals AC and BD are chords, that is intersecting chords, and that is the final, that is the last part of our proof there, that in fact when you have intersecting chords, and of course you have these portions here, A times C, and multiply, or A times C is of course equals to D times B, and it can be proven.